Hello. So what I'm doing today is I'm solving stack questions from NeetCode Sheet. So shout out to NeetCode. First we'll be doing valid parentheses. Valid parentheses are what? Valid parentheses is that we will be given a string and we have to determine if all the parentheses are if it's valid if all open brackets are closed, must be closed. If they are open, they have to be closed. Open bracket must be closed in correct order. That means like this is false and this is true. Every closed bracket has a corresponding open bracket of the same type. That means there cannot be. So what can we do in this? We can make a stack and insert whenever there is a open bracket and pop whenever there is a closed bracket. So if we pop whenever there is a closed bracket and we didn't get the corresponding closed bracket, are getting, like if we popped and we get a curly closed bracket, then we should get a curly open bracket after we pop. That is only when it is valid. So yeah, we can loop over the string. We should make a character array for string. Sorry. So if any open bracket is found, we just push. And if we found a closed bracket and it is empty, then we'll just return false. Else if maybe we get this and stack.pop is not equal to the open version of this, then we'll just return false. This. Yeah, similarly like this. And whenever we looped over the whole string, you can just return if the stack is empty or not. Stack has to be empty. If stack is not empty, that means there remains a open bracket which does not have a closed bracket. We can take the solution now and put it to the next one. On to the next one. What we have to do in this? On to the next one. On to the next one. Now what do we have to do in this? We have to make a class min stack in which these should be there. Like there should be a push method, pop method, and top method which returns the top, and also a getMin method which should return the minimum of the elements in the stack in O of one time. Let's see how we can do this. The constructor would be empty. We can make two stacks. One is just a normal stack and one is for the minimum element. Like we will make two stacks. This is normal. And this should be min stack. Or pushing. In normal stack we'll just push the value simply. Yeah. But for min stack we'll check if either min stack is empty, that means there is no minimum element until now, then we'll just simply push. Otherwise we'll check that if this value is lesser than the current minimum. If it's lesser than the current minimum, it becomes the current minimum. So we'll check if the popped one is current minimum. Sure, there could be multiple minimums. Is current minimum, then we'll just pop it. Return stack admin return min stack.peak. This should work. remove the static from here as it was not earlier. So yeah, next one is this. So we'll be given a string in which we have to operate these two with this operation, the last two with this operation, then the result and the another one this operation. So that means the last two integers we get have to be operated with the next operation we encounter. Simple. What we can do in this is we can make a stack and then push the numbers and pop the last two numbers, operate them and push that again. As equals, we'll check if it not that means if it's a number or not. We'll check that. That means it doesn't have to be any of the operators. Yes, now we'll just push. Else this means it is a, so we'll just pop the last two. So if it is plus, so if s equals to any operator, like if equals plus, then we'll just plus the popped numbers, and similarly for all the operators we have to do the second popped one with the first popped one. That is a requirement. So num2 num1, and then just simply push the res again and return the last number, which will be there. Let's see if that works. Not. Next is generate parentheses. So in generate parentheses, we know that we need an open. We have two options. Either we can insert an open one, open parentheses, or a closed parentheses. But we can only insert closed parentheses if the open one is there, if the number of open parentheses greater than the closed parentheses. Simply. And we can put open parentheses only if the number of open parentheses are number of n. So yeah, with this we can make another function. Which updates our list. Make a list here. Stuff, strings, word recurs. In this we can add int number of open, int of close, n, nr, string stuff string res. So for the base case, that means if the length string's length is equal to this, and we'll just simply add the string in the list and return. And for our first option, if open is less than n, then simply we recurse for open plus 1 close same and s plus open 1 and rest same as. And if closed less than open, then we'll recurse for the closed ones and insert closed one. Yeah, I think this will do. We'll just recurse for because first we have 0 number of open closed from there n and an empty string. This and res, yeah, and then return res. Let's see if it does something or not. We put a semicolon. Yeah, oh, we have to array list this. It's also done. So yeah, daily temperature, what we have to do is we have given consecutive temperatures. Okay, and we have to find when the next larger temperature comes, after how many days warmer temperature comes. So like 75 it's 4, 73 it's 1, this is 0. For this we can use stack, like we'll push until we get a bigger temperature. If we get a bigger temperature, then we pop until we get a bigger temperature. That means like 75 we push, 71 we push, 69 we push, 72 we push, and 76 we pop, then pop, then pop, then pop, and then pop, like this. We push, 71 we push, 69 we push, 72 we pop for the 69, pop 69, insert 72, yeah, like this. First we make a stack. Integers. Stack. I didn't really like the name of this, so we can change this. We can just name it temp. Simply I++. So what we can do is we are going to push not the number, as number can be duplicates, right? So if we access the index of it, then it may be disparity. So we're going to push index and pop the index of it. So if either stack is empty or temp I is less than stack dot peak, and we'll push I. Else not equal to. Else what we'll do, while either until stack is empty will pop, or when we encounter a bigger integer. Stack. If stack's peak is greater than the temp of I, until we will do stack. We should make an array also, int result equals new int of the same size as the temp. So stack.pop would be the popped yes, and in the rest of the popped one we will insert I minus popped and stack dot push. And return the result. Let's run that if it works. Be bigger than the temp of what am I doing? A silly mistake. Shit. Next one is car fleet. Car fleet is that we have given a target position array, speed array, and a target. What we have to do is, so this next question is car fleet. So what we are given is we are given a position array and the speed array. This determines position of a car, this the speed of that car at that position. So what we have to find is how many car fleets are going to appear at the target. What is a car fleet? Car fleet means two cars. Imagine a car going forward and a car behind it, which is faster than the car in the forward. So the first car which is moving slow will be caught by the second car, and after they get caught, they will move at the speed of the slower car. Then this makes a fleet. Yes. For this we can do, first we can sort the position array, so that we can get which car is first and all the cars for which we can make the fleet. Like the first car will make the fleet first, then others. Like we can see which are going to collide from the first car. Yes. Before that we can make a hash map so that the speed of position, because position is getting sorted, so it's getting all jumbled up. So therefore we couldn't get the hold of speed. So for getting the hold of speed, we can make a hash map. Yeah. Now we can fill the hash map. Map dot put I and its corresponding speed. Now sort the position array. Now what we can do is, now that position array is sorted, we can implement a stack. What the stack will do? Stack will insert the time. Actually the time is main here, because see, the first car is going to suppose the first car is going to reach the target at 10 minutes, and the car behind the first car is going to reach at the target at 5 minutes. So therefore they have to collide, because the car behind the first car cannot reach before the first car, so they have to have a fleet. So yeah, we can make a stack to track the time, and whenever we will compare the fleet master, you can say, make a fleet and a fleet master which has the fleet like the first car, and compare it if they are going to collide or not. If they are going to collide, then we'll just simply push the fleet master again into the so we are going to pop that car which is going to collide, because that is going to be one fleet only. So in the end we'll get a stack with the size of the fleet. The size of the stack will be the number of fleet. Should make it double. We will iterate from behind in this, so that we get the closest car first. First we should get the time. Should be in double. So that we didn't get the integer division, we get the decimal division converted to double. Target minus and we'll push it into stack. Time. Cut. So we will check that if stack's size is greater than or equal to 2. Because if the size of stack is 1, the fleet is going to be 1 and is going to be 1 only, the size of this stack. We'll pop now. We'll pop to see who is leading the fleet now. So and the car which is not in fleet and is behind. If we found out the time of the top is lesser than the time of pop, that means lesser than the car before it, so that means cut. That means they are not going to make a fleet. So we have to push the pop again. And return the size of stack at last. This should be greater than. And he's done it. Yo.
So please, sabara karay, Saraka, whatever. Please, I want to reach 1 million likes. So please, sarapakara. Okay, thank you.